This lesson, we're going to review writing and solving equations. I want you guys to take 1 to 3 minutes, solve the do now. It's a little bit of a review of solving literal equations from the previous lesson. Pause the video if you haven't. So, our do now, it says we want to solve for y2. That means we're getting y2 by itself. And we want it in terms of m, y1, x1, and x2. So the first step to getting y2 by itself is, well, you have to look at what's happening with the y2. It's being subtracted, well, it's subtracting y1, and it's also being divided by x2 minus x1. What you're going to want to do here is you're going to want to multiply both sides by x2 minus x1. You do not want to add by y1. If you add by y1, it's not going to cancel anything out on the right side and get y by itself, because you add y1 on both sides, you're not canceling out the y1, because this y1 is getting divided by x2 minus x1. So you can't just add y1. That's just going to make both sides even messier and not cancel anything out. So we want to multiply by x2 minus x1 on both sides here. That gets our denominator x2 minus x1 to cancel over here. So now on the right side, we're left with y2 minus y1 equals m times x2 minus x1. We want to get y2 by itself. So I'm going to do the inverse operation of subtracting y1, which is adding y1 on both sides. And your answer should be m x2 minus x1 plus y1 equals y2. Now you could distribute that m in if you want and make it m x2 minus m x1 plus y1 equals y2. Both of those answers are equivalent answers and are completely fine. What should I know by the end of the day? So I can define a variable within the context of a question using a let statement. I can write a 1 or 2 variable equation with a given context, and I can solve a 1 variable equation within a given context. So let's take a look at 1 and 2. Take a look at number 1. I want you guys to just write the equation for number 1. Pause the video, take 1 to 3 minutes, read number 1, and find its equation. So Devlin's baseball team is purchasing jerseys. The company charges $300. I like to underline all the numbers and their description for a one-time setup fee. That's important. One-time setup fee. So we're just charging that $300 just once. And $34 for each jersey. That for each is crucial, because when you see that for each, that means that's going to be the rate of change. 34 is going to be the rate of change. If the baseball team spends a total of $1,014, write an equation to represent the given situation. So let's first write our let statement. Our let statement, it's going to be what the x value, our variable is going to be here, and our variable is going to be what is with the rate of change. So that is, we know that this is let each printed jersey is $34. So that's what our x is going to be. So our x is going to be let x equal number of jerseys. And now we have to write our equation. So it has a total of 1,014. So that's going to be, whenever you see total, that means equal. So it's 1,114. And it charges a one-time fee of $300. So that $300, nothing's changing about it. It's just $300, and we're adding it on because it's a one-time fee. And then each jersey is $34, so that would be 34 times X. And once again, once you see each, that's a very nice hint that that is going to be the rate of change, because the rate of change is for each change in X. So number 2, take 2 to 4 minutes, do number 2, and also solve number 2. Looking at 2, Kai and Brett are brothers. Okay, Kai is 5 years less than twice Brett's age, which is X. Okay, the sum, so we know we're going to be adding their 2 ages, is 68. Write an equation that represents this relationship and solve to find each brother's age. So let's first start with our let statement. And I know I was like this. I know a lot of people are like, I don't want to write a let statement. I don't think it helps me that much. And to be completely honest with you, sometimes that's true. In some like easier problems, that let statement doesn't help at all. But especially when the questions in the scenarios get more complex, these let statements are really going to help. So I know these 2 aren't like the most complex questions we're going to be writing equations with, but when it gets really complex, those let statements really, really do help. And they also help because, say for some reason you're stuck on it, they let you kind of have like a starting point. Like, okay, I know what my variable is. Now I can write my equation. So we're always going to do the let statement. So let X, and in this question it tells us what X is. It's just Brett's age. It says right here, Brett's age X. So let X equal Brett's age. And make sure you put a let there. If you don't put a let there, you're saying the answer, you're just saying X is equal to Brett's age. You're saying the answer is Brett's age. You're not actually saying what the age is. So make sure you put a let out in front of that. Okay, so now let's piece this equation together. So we're adding, I'm just going to write it in words. So we're adding Kai plus Brett because of the sum. And we should get their 68. So I know Brett is X. That's not changing anything. I know 68, 68, good. And we're adding Kai, but now we have to figure out what Kai is. So it says up here, Kai is 5 years less minus than twice 2 times Brett's age, 2x. But this is the important thing whenever you see less than. And they love to use less than a lot in word problem questions. Whenever you see less than, it is subtraction. You have to make sure you flip the order. So that would be 2x minus 5 would represent Kai's age. So whenever you see less than, flip that order. So we have our equation here. Now we're just going to solve it to find each brother's age. So this would be add like terms, 3x minus 5 equals 68. Add 5 on both sides. You should get 3x equals 73. And I'm going to divide by 3 on both sides. And you should get x is equal to 73 over 3 years. I'm just going to write that as a decimal because I think it's easier to write. So x is equal to 24.3 repeating. So that's Brett's age. Brett is 24.3 repeating years. And now we just have to find out what Kai's age is. So we're going to plug that x value into Kai's age, which remember, Kai's age was 2x minus 5. So that would be 2. Then 73 over 3 is our x value, minus 5. That would be 131 over 3, which 131 divided by 3 is 43.6 repeating. So Kai is 43.6 repeating years old. Should probably add that to Brett also, years old. So that's it for this one. Let's go on to the next page. I just want you guys to take, 2 to 5 minutes, read this problem over, and solve both parts. So write the equation, and then use the equation to find what the second part is asking to find. Pause video if you haven't. So Jim is a furniture salesman. His weekly pay is I'm gonna just start underlining when I see numbers 300 plus. We know that's gonna be a plus sign. 300 plus. Make that better plus sign. There you go. 3.5%. So 3.5%. We do not want to use percentage in our actual equation that we're writing. Remember, to take a number out of percentage, you do whatever it is, the percent divided by 100, which essentially just moves the decimal place over to the left, makes it a smaller number by 2 place values. So that would be 0.035 would be the number we want to use for 3.5% of his total sales for the week. Jim sells X dollars worth of furniture during the week. Write an equation which can be used to determine his pay for the week Y. So Jim sells X dollars worth of furniture during the week, and we want to determine his pay, which is Y. So I'm just going to do my let statements really quick on the right. So I'm going to say let X equal exactly what's telling us, dollars worth of furniture sold during the week. And Y is his pay for the week. Let Y equal pay for the week. So his pay for the week compromises of two things. It compromises of the $300 and also the 3.5% of, remember, of in math means times, his total sales, which is X in this case. So our equation, we want to find his total pay for the week, which is Y. So Y equals. It's going to be exactly where it says his weekly pay is 300 plus 3.5% would be 0.035 of his total sales, which is X times X. That's going to be our equation. So step 2, it says use this equation to determine Jim's pay to the nearest cent for a week when his sales total $8,250. So this is also why let statements are nice, because this $8,250, it could be the X or the Y, but our let statement for X says the dollars worth of furniture sold during the week, and that is what the 8,250 is. So this would be Y equals 300 plus 0.035, and our X in this case, we know it. The total sales is 8,250. So just plug that in your calculator, and you should get Y equal to $588.75. I believe that's it for this page. Yep. Let's go to the next page. And this last question has 3 parts. I'm going to recommend we go part by part, and you pause the video for each part and then replay it. But you're more than welcome to just do the whole thing and then check at the end. So take a second, read the first part of this, or do the whole thing, and write the equation to determine how many months the boys will owe the same amount. Pause the video if you haven't. So let's take a look at, there's two different things happening here. Ian is borrowing money from his parents, and Ken is borrowing money from his parents. So let's first take a look at Ian. Ian is borrowing $1,000 from his parents to buy a notebook computer. Okay, and he plans on paying them back at a rate of $60 per month. And then we have Ken. Ken is borrowing $600 to purchase a snowboard, and he plans on paying them back at $20 per month. And it says write an equation that can be used to determine how many months the boys will owe. This is the key word. The same amount. Whenever you see the same amount in math, or the word the same, it's always an equal sign. So we want to know when Ian is going to equal Ken. So we have to send Ian's situation equal to Ken's situation. So if he owes $1,000 and he's paying back $60 every single month, that means Ian is starting off, think about this in terms of how much he's owing. He's starting off owing $1,000. And then each month he's chipping away at that money. So a lot of times when I see students do this, now this is not correct. They say plus 60x here. But think about you being Ian. If you're paying your parents off $60 a month, and you add 60 to how much you owe them, you're just technically owing them more. So after 1 month, if we're trying to write how much is being owed, you're gonna owe them $1,060. So that's not what we're trying to do. We're paying off the amount. So it's not going to be 1,000 plus 60x. It's be 1,000 minus 60x, because we're subtracting 60 every single month from how much we owe. And that's going to be equal to, because it should be the same as Ken's situation, which Ken's situation, he's borrowing only $600, and he's paying off at a rate of $20 per month. So that's going to be our equation. We set Ian equal to Ken. The big thing is we're subtracting there, because we're paying off the $1,000. We're getting a smaller number each time when we pay it off. So go ahead, do the next part. Pause the video if you haven't. Play it when you're done. So now we have to determine how many months the two boys will owe the same amount. So we just want to solve for x here. I'm going to set back up my equation. 1,000 minus 60x equals 600 minus 20x. I'm going to get all my x's on one side and my constants on the other. I want to keep my x positive to eliminate any future mistakes. So I'm going to add 60x on both sides, which means I have to get a constant on the left side of the equation. Oops. Plus 60x. That'll be minus 600 minus 600. We would be left with, on the left side, 60x's cancel. We're left with 400 equals, the 600s cancel, 40x. Divide by 40 on both sides, you should get x equal to 10. So state the amount of time they will owe the same amount. That would be in 10, and it is in months. So make sure you label that 10 months. So I want you guys to try the final part. Pause the video if you haven't. So there's a lot of ways of doing this next problem. I did it one way on the answer key. I'm going to do it a different way on the video. So it says Ian claims that he will have his loan paid off 6 months after he and Ken owe the same amount. So he and Ken owe the same amount in 10 months. So 6 months after 10 months would be 16 months. So Ian's claiming he's going to have his loan completely paid off after 16 months. So remember, Ian was on the left side, so he was 1,000 minus 60x. So 1,000 minus 60x is Ian. And if he has it completely paid off, that should equal 0. So that when is he gonna have absolutely no money owed to his parents? So I'm just gonna solve for x from here. So subtract 100 on both sides, you get negative 60x equals negative 1,000. And then I'm gonna do 1,000 divide by negative 60 on both sides. And you should get x equal to 16.6 repeating. And that would be in months. So will Ian have his debt paid off in 16 months? Or in other words, 6 months after he owed the same amount as Ken? And no, it takes him that extra 0.6 repeating months. So he's not going to have it paid off at 16 months. So determine if Ian is correct. Ian is incorrect. He will need more than 16 months to pay off his loan. And just for added measure, I'm going to say he will need 16.6 repeating months. So that's it for these notes. There is classwork after. And that's it.